Good day. My name is Maria Norma Matienzo.
And I am Raymond Christian G. Obra.
And I am Mark Luigi Rocaberte.
And I am Richmond Andrew Benedict S. Abulensya from San Pedro Education Center National High School Main Campus. The research entitled Garbotron, the development of Arduino Uno board-based smart environment waste segregation system.
When we talk about wastes, we come out in our mind about the wastes that is thrown anywhere, about the garbage that is not in a proper way. That is pollution waste. Pollution waste is relevant not only in our school, not only in our country, but in the whole world. And that is why we need to find a step, an action to stop pollution waste. Not totally stop, but to lessen it. And that is why we will discuss our research title, which is entitled Garbotron, the development of Arduino Uno board-based smart environment waste segregation system. Now, let's tackle out our introduction. According to the Second International Conference on Intelligent Computing and Control System 2018, the increasing volume of waste pose a significant threat in different sectors, such as the air quality, water resources, and environmental sustainability. And automatic waste segregation emerged as a solution on this problem. Furthermore, according to the International Solid Waste Association 2019, automatic waste segregation can help to improve recycling rates up to 20% and reduce landfill wastes. This can be used in schools, workplace, and in public places. Of all the countries in the world, waste management is a major global challenge, including the Philippines with population of over 12 million and producing 35,000 tons of waste daily. It is not surprising that we face similar challenges in other countries. And now, let's move to our rationale. As what I said before, the increasing volume of waste has a significant impact in different sectors, like human health, economy, and especially the environment. The aim of this study is to make automatic waste segregation more affordable and accessible in every community, to help maximizing reuse and recycle, creating systems that help every community while being eco-friendly and efficient.
For the literature review, according to Endaya et al. 2020, emphasizes the global urgency for efficient waste management due to environment and public health concern. MD Abdullah at Rakim et al. 2021 spotlighted challenges in developing nations tied to rapid population growth and inadequate waste segregation. B.R. Santosh Kumar et al. 2019 addressed the metropolitan waste collection, hurdles linked to urbanization and lack of awareness, stressing the need of the population. World Bank Organization in 2018, with the proper waste segregation, we can eliminate the crisis of low recycling rates, particularly with plastic waste in our daily community. Republic Act 9003, which mandate the local government units to achieve 25% waste reduction, reduce, reuse, recycle. For the research gap, this study seeks to pioneer an Arduino Uno-based automatic waste segregation system, addressing a gap in the current literature by focusing on affordability and accessibility with a same function. Many communities, particularly low-income and developing ones, lacks access to the currently expensive and complex automated waste segregation systems.
Pograk's waste management theory says that waste is not just stuff we throw away. It includes materials not being used much. It focusing on stopping waste, encouraging more use and recycling, unlike regular waste. It suggests managing waste in everything we do, like making products and using them. The goal is to change and improve how we handle waste for the health of people and the planet. We use IPO because we're developing something which is Arduino Uno board-based automatic waste segregation system. The process that we do first is program coding. Here we try different types of code that can be used to Arduino Uno. After we find the codes that we need, we can develop an Arduino Uno board-based for the environment waste segregation system. And for the validation of instrument with the help of teachers, they will help us to validate the instrument we will be using in conducting this research. The next is product testing. Here we will test the product's function and to know if the product really works or not, basically trial and error. And And lastly, for data gathering. Here we will gather all data that we need for the research. Also, in this process, we will know if our product is really effective in participant point of view.
And for the research question, the study introduced Garbotron and Arduino Uno-based waste segregation system to enhance recycling and reduce environmental impact. It evaluates Garbotron efficiency in waste sorting compared to the manual methods, particularly in residential and environmental contexts, while also examining its contribution to increase recycling rates and decreasing community waste volume. Additionally, the research investigates the mechanism and broader implication of Garbotron on waste management practices.
And for the research design, the study proposed a technological intervention using Arduino Uno following the Sajowski 2018 recommendation for quasi-experimental design. It will rely on pre- and post-intervention data to evaluate the impact of Arduino Uno-based trash segregation system on efficiency and environmental outcomes.
The participant of the study, the researcher have chosen San Pedro Location Center National High School main campus due to its diverse participant pool, which will help make the study finding more widely and applicable. They use a stratified sample strategy to ensure a precise participant selection. Aiming for a responsive sample, through interview, they collect quantitative data from a total of 78 participants, identified using the slotted technique. This group comprised 37 participants from STEM A and 41 participants from STEM B, all crucial for the study and objectives.
By utilizing questionnaire interview in Lapus building of San Pedro Location Center National High School, the STEM student may answer based on their perspective on automatic waste segregation using Arduino Uno to improve and innovate the product of this research.
And now let's move to the data collection of our research. Data from the survey questionnaire will be used to assess the effectiveness of the Arduino-based automatic waste segregation, and the information obtained from it will be helpful in determining whether it is effective than the traditional segregation. The result of the survey questionnaire will be taken into account and will be used as the foundation for the addition of new guidelines for the implementation of automatic waste segregator. The automatic waste segregation will undergo the necessary modifications to ensure its effectiveness. For ethical consideration of our research, before the study began, consent from the school principal was sought as per ethical consideration procedures. The data collecting devices were validated through experts to ensure the practicability, usability, measurability, and ethicality. Informed consent and an asset form will be given by the parents and students of STEM before they answer the given survey, indicating that they are voluntarily participating in research. There will be a letter that they will read before they undergo answering survey questionnaires and rating for, and before taking a video or audio recording for the interview. As a result, data confidentiality was ensured and participants' names were kept a secret to shield them from any potential repercussions. In reporting the results, pseudonyms were employed in place of the participants' real names. Additionally, the researchers only kept data on their computer for 2 years. All information will thereafter be deleted.
This research will utilize quantitative descriptive analysis to describe variables related to waste prevention and the effectiveness of waste segregation in the research titled Garbotron. This method aims to provide a detailed understanding of these variables. The plan to calculate the mean and standard deviation using a formula to analyze the data gathered, and the researcher plans to calculate the mean and standard deviation using appropriate formulas. By providing insights into the central tendency of the data gathered, the statistical analysis will help to gain a deeper understanding of the evolution of the Garbotron system and how it affects waste segregation in smart environments.
For the resulting discussion, the study suggests that automatic waste segregation, particularly with innovative deep learning algorithm, is more effective than traditional methods. However, it is also notes unexpected results regarding reusing and recycling. Despite this, automatic segregation, especially with the Arduino Uno, is seen as beneficial for improving waste management.
For the findings of our research, the study developed an automatic waste segregation system to improve waste sorting. Grade 12 students evaluate it using questionnaires, rating it fairly positive across all the variables: waste prevention, reuse, recycling, and effectiveness of it. While perception differed, there is a significant difference on waste prevention and segregation effectiveness, while there is no significant difference for reuse and recycling.
In conclusion, the study demonstrates that Arduino Uno-based automatic waste segregation system enhance waste sorting, increase recycling rates, and reduce waste in disposal facilities. It stresses the importance of affordable and accessible technology for widespread adoption, while highlighting the need for continuous innovation to keep the technological advancement in changing needs.
And for the recommendation, prioritize adopting an automatic waste segregation system with Arduino Uno technology to boost waste management and sustainable goals. This system enhances public awareness and support global sustainable development goals by optimizing waste collection through precise sensors and proactive alerts. Integrating webcams, soil moisture sensor, and bin fill alerts improve user engagement and efficiency. Continued research is essential for enhancing this system and fostering a greener future.
The sequence of our segregator product, or the Garbotron, is ultrasonic sensor, water sensor, and inductive sensor. Where ultrasonic detect the dry waste, the water sensor detect the wet waste, and the inductive sensor detect the metal waste. If the waste is metal waste, the first one to detect is the ultrasonic sensor, and the next one is the inductive sensor, and the waste will go in the metal waste bin. If the waste is wet waste, the first sensor that will detect is ultrasonic sensor, and the next is water sensor, and the waste will go in wet waste bin. And lastly, the waste is dry waste. The sensor that will detect is the ultrasonic sensor, and the dry waste will go in dry waste bin.
Video na, be. Yan, metal. Ayun.